Hi, good morning, good evening, good afternoon, wherever you are. A very, very, very happy Women's Day to everyone. And those few men who may be listening to women speakers, you're a great supporter of women, and thanks a lot for being there. Today, we are going to talk about how artificial intelligence is changing the way healthcare is delivered to everyone. Of course, we start with a very, very key disease, which is cancer. And then, of course, we should talk about how it impacts COVID as well. So I'm going to share about my experiences in a couple of these use cases of using AI for healthcare. Before that, let's peek into the future of healthcare, just a few minutes and a few seconds. Definitely, there is no doubt that the future of healthcare is digital. No more are the days where the doctors used to prescribe on a sheet of paper and you're not able to understand what is the medicine they have written and so on and so forth. Everything is digital. Not just that, there are several technologies built around this digitized healthcare. For example, we have talked about augmented reality in a gaming sense, right? Something you go to a museum and you will see all of it. But think about how it can actually change healthcare. The doctor is operating someone and immediately she can see out there the x-ray or the MRI images which were taken last week, so that she knows exactly what she's touching. Or there's so many ways of looking into the body through multiple waves, right? Ultrasound, x-ray, thermo, and all of it, MRI, and so on. What if the doctor is able to look at all of it one after the other, and he or she is able to relate to what's happening within much better? We've always thought about gaming with driving cars. Today, we use similar controls for robotic surgery. A doctor sitting in the US operating somebody in India, and vice versa. What you're seeing in the right bottom is what is the view that the doctor gets. But there are a bunch of surgical instruments controlled by technology that are actually doing the surgery. Then, of course, these 3D printing, precise cutting of, for example, how this earplug sits into your ear, or even, of course, now it's being used for rockets as well. But yeah, in healthcare, it can be extremely helpful to have precision surgery and precision replacement of parts. Not but not the least, and something that's favorite to all of us is data science. Of course, data science and AI, ML, all of this is changing the way healthcare is delivered today. But in the future, how about thinking about it as an autonomous AI? It's going to do most of the work itself. Maybe it requires some high level supervision, but it is autonomous, automatically deciding different diseases or diagnostics wherever the doctors cannot go, or wherever the doctors are there helping them. This is what is going to be the main topic of today. Let's first quickly see, why do we need AI for medical imaging? Particularly, why medical imaging? First of all, many of us here know that AI really loves patterns, be it audio, video, pictures, that's when our deep learning networks works really well. Of course, it works for other reasons, other data types as well. But here, that is where you can actually have deep neural networks and do faster decision making. And medical imaging also needs AI. For example, there's a huge global shortage of radiologists. In India, for example, I'm told that one radiologist needs to cater to 1 lakh patients. If you look at just a generic doctor, a doctor has to serve 1,800 families. That is the ratio of patient to doctor. So you need something that can enhance the productivity of the doctor, make the doctor very fast and precise as well. And many times what happens when the doctor is reviewing thousands of x-rays or images, there can be slips. Every doctor, every human being is prone to errors. And when you have stress, there are likely to be more errors. And so we need someone else, like a second doctor, sitting next door and saying, hey, are you sure this is not a cancer? So that is what an AI robot can do for that, for improving diagnostic accuracy and reducing the misdiagnosis. At the end, AI is definitely going to help in improving patient outcomes, be it in terms of number of people served, how short is your waiting time at the doctor's clinic, but definitely how well you are, how precisely you got the medication that will treat your condition. So, Miramai is a startup we started 4 years ago. And, after spending a lot of years in industry trying to use AI for multiple different applications, and this is where I think I found my life's love. How to use AI for non-invasively doing risk assessment through machine artificial intelligence. That's what Miramai stands for. It also has an expansion, which is non-invasive risk assessment machine artificial intelligence, but it has a beautiful meaning in Sanskrit, which means being without diseases. So I'm going to go deeper and then talk about how we use AI to solve this biggest cause of cancer deaths in women today, which is breast cancer. 680,000 women died in 2020 because of breast cancer globally. That is huge. What is also alarming is this rate in India and other developing world. 90,000 women died last year in India alone. And the main reason is late detection. Everyone waits for a huge lump, to appear, to feel, and to actually go to the doctor. You don't need to wait for symptoms. Can we have regular screening, preventive screening, if you will, on an annual basis to detect very, very, very small early symptoms or early abnormalities that indicate a future cancer? Early detection is extremely critical to save lives. So, what are the gaps in current screening methods? Why are people not able to go there? First and foremost, many of you will be under 45, and unfortunately, current techniques do not work very well for women under 45 years of age. And these instances are becoming more and more today, even in younger women. And the reason is because the most popular method that's used for breast cancer screening, which is mammography, which is a wonderful tool to detect early stage breast abnormalities, microcalcifications. However, because it's based on X-rays, it's like our hand, right? If there is an abnormality or something that is hard, it comes white. So an X-ray is like that, and you can see two women there. One is a 60-year-old, and the next one is a 40-year-old. 40-year-old or a younger woman has dense breast. A lot of fibroglandular tissue, which is doing a lot of work inside, right? But that appears white. And so, if there is an abnormality which is white, like a microcalcification, it gets unnoticed. So, it is known in literature that my mammography has lower sensitivity. So far, it was good, but because of changing lifestyle and so on and so forth, the age of breast cancer is coming down. So, what is the test to use for these women? They have a long number of years to go, and so it better be healthy. When you come to the developing world, it's also an affordability accessibility check. So we said, can we do something about it? And bingo, we have an AI-based solution to address these issues. What we have done is to just measure the temperature variations on the chest using thermal imaging and developed an artificial intelligence, machine intelligence essentially based solution, which analyzes this 400,000 temperature points and generates a report saying whether there is an abnormality or not. This can detect very small lesions of size of 5 millimeters instead of hand-based detection, which can detect 25 millimeters, so 5 times smaller. It's completely non-contact, non-invasive, where nobody touches the patient or sees the person. I just enter into a booth, stay there for 10 minutes and come out. Nobody would have seen me or touched me. And that privacy aware is the solution. No radiation, just measuring the temperature. All of you have seen thermal imaging devices, thermal cameras in COVID time. That's exactly what we use. However, it's a very high resolution thermal sensor which can measure 400,000 temperature points per person. It does work on women or all age groups, and it can work on men too. Just pretty affordable and accessible. The technology we have developed is called thermal analytics, which uses thermal imaging to measure the temperature variation. And the center picture you're seeing is a thermal image. It's a heat map of 400,000 data points, where every point here is a temperature. White color could be 38 degrees Celsius, red could be 37 degrees Celsius, yellow could be 36, and so on and so forth. And a software which is machine learning enabled generates this report or an analysis saying where is an abnormality likely to be and what is the probability that it is cancer. It is patented. There are 10 US patents, Singapore, China, India, all of these patents are there. So it's very unique. So we don't look for lumps, we look for abnormal tissue activity. It is computer-aided diagnostics with AI enablement. The report that is generated is completely automatically generated for camps because it's a small device. You can take it out and do the camps in rural areas and so on and so forth. And there we generate a red, yellow, green automatically. In a hospital, it's a radiologist certified report where there is a huge full report with scores, which are called thermobiological score and so on and so forth. These scores indicate whether there's something abnormal. We also generate these images where there's a picture of the frontal view and left right view and so on, and also a marking of where the likely abnormality is. It's a very small device. Where that small device you see between the two cute girls, that is the device, which is an off the shelf thermal imaging device you've seen in airports and so on. It's the same device with a high resolution, as I mentioned. This is installed in 70 different hospitals in India, in 15 cities. And many women, 34,000 women have actually taken this test so far. All the magic is because of AI. We have also done 2,000 plus outreach camps in this, and a bus which just has a small room which does Miramai screening because it doesn't use X-rays. It can be done anywhere. I request the organizers to play a small video which shows the experience of this test, and then I go on to the tech.
Recently, I lost a family member to breast cancer, and I know that as a woman, breast cancer is something that I have to keep checking myself for. Unfortunately, there's no way that is safe, reliable, and easy to find out about malignancy. While doing a lot of research and discussing this issue with my friends, one of them suggested the Niramai technology to me. Having heard about it, I went to get a checkup done. I was quite skeptical before I went for the test. It took me by surprise because the machines didn't touch me. It was all happening from far away. जैसे आई टेस्ट होते हैं ना, दूर से बिल्कुल वैसा.
Yeah, definitely. Early detection is very important. And that gave you a glimpse of how to do early detection. So, where's the technology? The core innovation is AI. So, what we get is a thermal image, as I mentioned. And what you see on the screen are four images of four different ladies. The first one is normal. The next one has an abnormality in her left breast in the center part, which is upper inner quadrant. The bottom two look very similar, like some lot of red spots and so on, but they are not at all cancerous. It's like hormonal reaction or a cyst. That is where AI can play a role, machine learning can play a role. So we use several features of these thermal images, including definitely symmetry between the left side. We have 30 different ways of modeling this symmetry. We use thermal distribution inside what's called as hotspot. And we have a new algorithm to detect circular cylindrical structures called vascular analysis. And we look at vascular structures between the left and the right side, and so on and so forth. That gives us a handcrafted model for the final diagnosis or an indication of final diagnosis. But there's several places where machine learning can be used. A garbage in is garbage out. So if the image is taken by the technician is not good, the answer won't be good. So we also start with image analysis, pre-processing. Let's take an example. The lady takes 5 views, the technician. And sometimes we found the health workers are marking left as right, right or left because it's a mirror image. Like they get very confused. So the easy thing, develop a 5 class classifier which says is frontal views and left lateral, left 95, left 45, sorry, left 90, left 45, right 90, right 45. So this is a classifier. First we developed using image processing, and then bingo, deep learning made it 97% accurate. Another, we take the image of the whole area, but we just need to analyze the breast to have a maximum accuracy. So we had to find the breast region in a thermal image. So first we tried with an image processing algorithm. Next, after some amount of data was got like 5,000 images, then we developed a two-phase deep learning architecture based on CNN as well as VNet, and then we got wonderful results. What you see in green is the result of deep learning network, which is precise marking of the breast area, whereas the yellow one is more a heuristic, which is looking at the contours of the body to find it. And yeah, here again, we were able to get 92% dice similarity, which is actually same as human similarity, human matching. And then, of course, I don't need to define to this audience what is machine learning, particularly supervised machine learning is what this picture shows. Yes, we just use a two-class classifier for the final diagnosis. The catch is, instead of labeling the thermal image using manual labels, that is, today there are not many doctors who can look at a thermal image and say whether it's cancer or not. So if you show a doctor, even a radiologist who's trained, there will be several different answers. If you Google thermal imaging, you get a lot of controversial thing. It does work, it doesn't work, and all of that. That is because there are different people giving different type of results. So we said, let's not even go to thermographers to get the data label. We did a very smart thing, I guess, which is taking thermal image, making the same person go through mammography, ultrasound, and biopsy. And we trained the machine learning model from the biopsy result directly, not manual interpretation of thermography, which is already faulty. So a biopsy trained machine learning model is much better than thermographers, actually turned out to be better than mammography as well, surprisingly. And so let's see the accuracy a little bit. Yes, we have done about 34,000 or 35,000 women so far, and many, many international publications on this. And one of them, which I'm very proud of, is the ASCO Breakthrough Summit. This was held in Thailand. Those of you from Thailand, hi. Bangkok is a wonderful city. So we presented here, and you can see the orange bar. Orange bar shows screening accuracy. That is, people without symptoms. We were able to find, touch wood, all the cancers so far without symptoms. With symptoms, it becomes a diagnostic test. And there again, we have over 93% accuracy or sensitivity and specificity is what we use in healthcare. And the same thing in mammography is pretty low because of the density of the tissue that I mentioned. It's about 67% there. And also many women could not go through mammography because they were under 45 years of age. This was a very, very promising result. So it also got published in a different journal, which is a journal of clinical oncology, which is a very, very top tier journal. Those of you interested can actually go through the details of that. Now let's shift gears for last 2 minutes and look at how we tried to use the same technology of thermal imaging and AI for COVID-19. You know, COVID-19 locked off all of us in our rooms, in our houses. But when offices got opened up, public places got opened up, it was very, very important to look for COVID symptoms at the minimum in people who are walking around. So we developed this technology where the thermal camera is actually viewing the different people who are walking in a public place like a railway station or a hospital or school or college, and automatically does a face detection, detects what's the temperature, and then raises alarm of any person who requires to be sent to the side, right? This is completely automatic and installed in 30 different places in also multiple railway stations in India. Second, we use chest x-rays to say whether there is likely to be COVID or not. There is a data set available, and if those of you who want to play with it, chest x-rays is the best place to start with because there's a huge amount of tagged data that's available. And this is again something that we released for villagers to actually, basically doctors who are serving the villages to actually immediately know whether a person needs to be sent to a district hospital when he comes with a symptom. This whole technology has resulted in many awards, including a handshake with Bill Gates, which I'll never forget. That was in November 2019. And we happen to be the only Indian startup listed on the top 100 AI startups in the world. So, with this, I would like you to invite you essentially to use AI to save many, many lives. And Niramai is attempting to do that from COVID to cancer or cancer to COVID. Thanks a lot. Wishing you a very, very healthy year and a happy Women's Day. Thank you.